Let's look at the figure which is there. Given a point O in the plane and a positive number R. Okay? The set of all the points in the plane that are at a distance of R units from this point O forms a circle. So, circle is collection of all the points on a plane which are at a fixed distance, and that distance is your radius. From a fixed point, which is known as the center of the circle, forms a circle. So if I collect all the points on this circumference, also you can refer to as the perimeter if you are comparing it with a polygon, which is at a fixed distance. So all the points that you have here are at a fixed distance, are from the center of the circle. Okay? The diameter of the circle is given as twice the radius. So, radius is from the center to the circumference. Diameter is from one end of the circumference to another end of the circumference, passing through the center of the circle. The diameter of the circle is twice the radius. If I talk about the circumference, which is the length of the perimeter, is given by 2 pi r. 2 pi r, twice the radius multiplied with pi. Pi is a constant and the value of pi is approximately taken as 3.14 or can be taken as 22 by 7. So I can take 22 by 7 or 3.14 as the value of this pi. The area of this circle is given by pi r square. Pi into square of the radius is what your area for this circle comes up. Now the area is this complete area which is inside the circumference of this circle. So circumference is length of the perimeter and area is the surface area that you have for this figure. The units for circumference will be same as the units for radius since pi b is a constant. So if the radius is in centimeters or meters, the circumference will be in centimeters or meters. But the units for area are square the units for radius. So it will be either centimeter square or meter square or kilometer square, depending upon what are the units for radius that I have in question. Moving ahead, we need to understand few other terms. One of such term is an arc. Arc is a part of circumference. So if I randomly put any 2 points on the circumference, which is dividing the circumference into 2 parts. One is this part, another one is the smaller part. So the smaller part is known as minor arc. Minor refers to the smaller part and the bigger part refers to as the major arc. We need a minimum of 3 points to understand clearly what an arc is representing. So if I say PQ is an arc, PQ could be a major PQ arc or a minor PQ arc. So if I mention a third point PRQ, I know that I'm referring to a minor arc. Or if I say PSQ, I know I'm referring to a major arc. So PRQ and PSQ are the 2 arcs of this circle. The next one being sector. Sector is a part of the circle bounded by the arc of a circle and the 2 radii. So sector is basically a part of area of the circle. So if I join the 2 endpoints of the arc with the center of the circle, P joined with the center of the circle and Q joined with the center of the circle, the part of the area that I get refers to the sector. So it's a part of the circle which is bounded by arc on one side and the radius on another 2 sides. It's just like a pizza slice. So what you have complete is a pizza, and what you have sector is a slice of the pizza. Arc will be the boundary of the pizza that you will have. Okay. Now here P, O, Q, R, P. P, O, Q, R, P has a central angle of theta. Central angle means if I join the two endpoints of this arc with the center of the circle, the angle subtended at the center is theta. Now I need to know that the total angle subtended at the center with the circle is 360 degrees. So this theta would be less than 360 degrees. It will be a part of 360 degrees. Another very important thing that I need to always keep in my mind is that if I take the following ratios, all of these ratios would come out to be constant. So theta, which is the angle subtended at the center by an arc, over 360, which is the total angle, would be equal to the length of this arc over 2 pi r. 2 pi r is the circumference of the circle of length of the perimeter of the circle, is equal to the area of this sector divided by the total area of the circle, which is pi r square. So in case I need to find the area of the sector and I know the angle subtended at the center, I could use both of these and find out the formula for area of the sector. That will be given by theta over 360 into pi r square. To find out the length of the arc, I could multiply 2 pi r with theta over 360 and subsequently I will get the formulas. So this is a very important relationship that I need to keep in my mind whenever I am solving a question based upon length of the arc or area of the sector. Let's look at an example. What is the area of the sector AOB with the center as O shown below? Now if you look at it, AOB. Now AOB could be this one also and could be this one also. So there's no clear mention about what is AOB. Now if I look here, the angle which is mentioned is this angle. So it is a little bit obvious thing that he's asking me about this area. Now if I remember the previous relationship that I've just learned, which was theta over 360 degrees is equal to the area of the sector divided by pi r square, which is the area of the circle. So area of the sector would be given by theta over 360 into pi r square. The value of r which is given to me in the question is 4. So I'll just put down the value. I can put the value of theta is 225 over 360 into. Now pi, I need not put the value because all the answers that I have are in terms of pi. So this will be into 16 pi. So what I need to do is I just need to solve these values and I will get to my answer. Now what I can do is I can just approximate the answer as well. Instead of using the calculator, instead of manually doing this, I can just calculate the thing. Now what I look at is this 225 and 360. 225 is more than 50% of 360. 360, 50% is 180. So had this been 180 over 360, I would have got a factor of 1 by 2, which multiplied by 16 pi would have given me 8 pi as my answer. Right? So if I just look here, 8 pi could not be my answer because this is more than that. So if I just look at here, the answers are 3 pi, 4 pi, 6 pi, 8 pi and 16 pi. If I just do a half of it, right, this will be 8 pi and this will be 8 pi. So now if I look at the answer options which are available to me, my answer cannot be 3, 4, 6, 8 or 16, right? So that means the question that I've started with is a wrong question, or I should say the approach that I've taken is a wrong approach, because 225 if I take, my answer has to be more than 8 and less than 16, and there's no such option which is more than 8 and less than 16. So that means the question would have asked me this angle, this sector area. So it would have been pi r square minus the area of this. So if I just look at it, this will be an area which is less than 8 pi but more than 4 pi. This is 4 pi, this is all, if I divide it into 4 quadrants, all are 4 pi. So it will be more than 4 pi. So these two options are eliminated, but less than 8 pi. So the answer option that I have is 6 pi. So even if you're not clear about your question, you will see that the answer options will be in a way so that you get the correct. Let's move ahead and let's talk about the concept of a circular ring. Look at the figure that you have. A circular ring is a plane figure bounded by circumference of two concentric circles of different radii. Concentric circles, I mean two circles with same radius are known as two circles with same center are known as concentric circles. Their radius being different but their center being the same are referred to as concentric circles. So a circular ring is a plane figure which is formed by two concentric circles of different radii. If I have to look at the perimeter of this, perimeter is the length of the boundary. So this is the internal boundary that I have, and this one is the external boundary that I have. So the perimeter would be the internal boundary, which will be 2 pi small r, and the external boundary, which will be 2 pi capital R. Taking 2 pi common, I'll get my answer as 2 pi capital R plus small r. If I look at the area of such figure, I would clearly understand that the area of this ring would be given by area of the outer circle minus area of the inner circle. So outer circle area will be pi capital R square and inner circle area will be pi small r square. So the area of the ring would be pi capital R square minus small r square. This will be the area of a circular ring. Let's look at an example for circular ring. In a figure given below, the area of the larger circular section, so I have a larger circular section, right, whose radius is given by capital R, is twice the area of the smaller circular section. So I will look at it that pi r square is twice of pi small r square. I would get the relationship between the two radiuses. So the radius of the bigger circle is root 2 times the radius of the smaller circle. This is the relationship between the radii that I get. If the diameter of the larger circular region is x, so if the diameter is x, okay, so I can write this radius as diameter by 2, or I can write this as x by 2 is equal to r root 2. So I can find the relationship between r in terms of x. If I just this x over 2 root 2, okay. Then in terms of x, what is the area of the smaller circular region? Now the area of the smaller circular region is given by pi r square. I want it in terms of x. So r, I'll put the value as x over 2 root 2 and square of it. So my answer becomes pi x squared over 8, giving option number C as my answer. Anyways, otherwise also option number D and option number E could be discarded because the units are not matching with the units of the area. Area units are centimeter square, meter square, kilometer square. So here I am only multiplying it with kilometer or centimeter. I am not squaring it. So the answer option would be between first three and just putting in the values. I am getting option number C as my answer. Let's look at another question. In the figure given below, side yz of a square wxyz has length 2. So if this length is 2, that means this is also 2, this is also 2 and this is also 2. If w is the center of the circle, so this being the center of the circle, I'll get the radius of the circle as 2. Okay. And it's a square, so that means this angle that you have is a 90-degree angle. I know that the total angle is 360 degree, so 90 over 360. So that means this is 1/4 of a circle. or a quadrant of a circle. So if this is 1/4, the area of this will also be 1/4 of the circle, and the perimeter for this will also be 1/4 the perimeter of the circle. Now the question is, what is the area of the shaded region? So I have to find the area of this shaded region. If I find out the area of square and subtract the area of a quadrant. Quadrant, I would say 1/4 of a circle, I will get my answer. So what is the area of the square that you have is 4 minus. So if we just look at it, I know there's some answer options that cannot be there, like something like this. It cannot be 4 plus something. It cannot be 8 plus something. It cannot be 8 minus something. It has to be 4 minus something. Still, I'll just check my answer. 1/4 of area of the circle. Area of the circle is pi r square. R square is 4, so it is 4 minus pi. Anyways, without even solving, I knew that my answer was option number A. Moving ahead to another example. In the figure below, rectangle ABCD has a length 6 and width 8. So this is 8, this is 6. Rectangle means opposite sides are equal, opposite sides are parallel, all the vertex angles are 90 degree. There are two diagonals that I have. Now the length of this diagonal AC would be given by Pythagoras theorem, which is 8 square plus 6 square whole square root, which is square root of 100, which is giving me an answer of 10. So this 10 that we have as a diagonal of this rectangle is acting as the diameter of the circle. So I know that the diameter of the circle is 10. This means that the radius of the circle comes out to be 5. And I have to find out the area of the circle. So which is given by 5 pi r square, giving me 25 pi as my answer. Moving ahead, the question that we have is, if a square has an area x, then in terms of x, what is the circumference of the largest circle that can be inscribed in the square? If I just look at it, x has the units of area. So either it is meter square or kilometer square or whatever. Then in terms of x, I need to find circumference. Circumference should be only in meters. That means I need to take a square root of x. So if I just look at the answer options, option number C, option number D could be negated because I need to take the square root of x. Right? So I am left with only 3 answer options. What is the circumference of the largest circle that can be inscribed in a inscribed? That means inscribed means it has to be inside the square. So let's take a case. This is a square that we have. Now this square has an area of x. Area is given by side square. Side square is x. So what is the side that I have? Side I have is root x. So this is root x and this is root x. This side, both the side. Now I have to get the largest circle. Largest circle is possible only if it is touching all the 4 sides of the square, such as this. So this is the largest circle that can be inscribed inside a square. The thing to note here is that if I join this, which is the side of the square, becomes the diameter of the circle. So I would say that the diameter of the circle would be root x, or the radius would be half the diameter, which will be this. And I need to find circumference. I know that the formula for circumference is 2 pi r, or I can put pi into diameter. So pi into the diameter. Diameter is root x, giving me option number A as my answer. Moving ahead, we'll look at the question which says square ABCD is given below. The shaded region is the intersection of 2 circular regions centered at B and D. So at B, you have a circular region for which it goes something like this. Okay. it goes something like this. You have, I'm just trying to make it in rough, you'll have something like this. AC as one of the arcs, where AB, let me call this side, it's given in the question, this side is 10, 10 is the radius. And similarly, with D as the center and AD or DC as the radius, another circle is drawn. So I'm drawing a circle like this. Okay. Now this is the common region for the intersection of the two circles with B and D as their centers, and the radius of each of the circle being 10. The area of the shaded region is. This is what you have to find out. Now if I just look at this, what is the area of the square that you have? It is 10 square, which is 100, right? So if I just try to, put in the values here, I may be able to eliminate some of the options. Now if I just look at it, my answer for this common region would be much less than 100, because it has to be 100 minus something. So if I just try to figure this something out, I will look at and I will eliminate the option by putting pi approximately equal to 3. So if I just 3 minus 2 is 1. So first option is giving me it is 25 plus. I'm just approximating it. 50 into 3 minus 2. The second option is saying it is 50 plus. The third option is saying 25 into 3. So it is 75 plus. The fourth option is 150 plus. And the fifth option is 40 into 3. Which is what? 120 into something again, which is very big. So option number E and option number D cannot be my answer. Also, option number C seems quite large, cannot be my answer. So I'm left with two answer options with me. Now if I just try to figure it out with symmetry as well. Sorry, if I try to figure it out with symmetry as well, this is 50, right? In 50, I'm subtracting this, so it will be close to around what? Approximately what, half of that kind, or a little bit more than half. So I would say my answer that I'm getting is option number B. Let's look at another example. In the figure below, OPR are the centers of the three circles, each with radius 2. What is the perimeter of the shaded region? Now if I just understand, if I join OP, it will be a line that would measure 2, because it is from the center of this circle to the circumference of this circle. OR would also, it's a straight line. OR would also measure 2 and RP would measure 2. So it's a kind of equilateral triangle that you get. I know that the perimeter of equilateral triangle is 3 times the side, which is 6. Now if I look at OP arc, OR arc and RP arc, I would understand that the length of this arc would be a little bit more than the length of the line joining these 2 points. So the perimeter would be 6 plus. If I just put an approximate value of pi is equal to 3, I'm getting an answer of 2 plus, 3 plus, 4 plus, 6 plus, and this will be 8 plus. Now I know my answer is 6 plus, which is option number D. Therefore, option A, B, C and E are eliminated. Talking about the next concept of chord, I would say a line joining 2 points on the circumference of the circle forms a chord. So if you randomly select any 2 points on the circumference of the circle and join them with a line passing through the circle is known as a chord. A chord can be referred to as a line segment, since both the end points would fall on the circumference of the circle. I will have infinite number of chords in the circle. You randomly join any 2 points on the circumference of the circle, what you get is a chord. So there are infinite number of chords that are possible for a given circle, with diameter being the longest chord. Diameter is the longest chord for a circle that I have. The properties of chord that I need to know is Equal chords of a circle subtend equals angle at the center and vice versa. So if I suppose two chords AB and CD are equal in length, then the angles that they will subtend at the center, which is angle AOB and angle COD, would also be equal, and vice versa. So if the angles subtended at the center are equal, that means they have been subtended by equal chords. Another thing that I need to know is, if two chords which are equal in length, if there are two chords which are equal in length, they have to be equidistant from the center. So equal chords are equidistant from the center. And equidistant, I'm talking about the perpendicular distances. The perpendicular distance from the center would be same. And vice versa. That means if there are two chords which are at equal distances from the center, that means the two chords would be of equal length. So I would understand this as a congruent thing. So this triangle would become congruent to this triangle. So the length of the arc would also become equal. The length of the arc AB would be equal to the length of the arc CD, and OP, which is the perpendicular distance, OP will become the perpendicular bisector of AB. So a line joining the center of the circle perpendicular to the chord bisects the chord. So perpendicular from the center to the chord would always bisect the chord. From the center to the chord would always bisect the chord. Okay? And the triangles that I will get would become congruent. The triangle ORA, which is this triangle, will be equal to triangle ORB and congruent to triangle ORB, and AOB, this entire triangle, is congruent to the bigger triangle COD. All the triangles that you will get would become congruent to each other. Therefore, the angles subtended at the center would become equal, the perpendicular distances would become the same, the length of the arcs will become the same. Everything will be same because the figure that you get in this case comes out to be congruent. Let's look at a question. In the circle given below, chord AC has a length of 6. If the length of arc ABC is equal to 1/6 of the circumference of the circle, what is the area of the circle? Now what is given to you is the length of the arc ABC. The length of this arc is 1/6 the circumference of the circle. So circumference of the circle is 2 pi r. It is 1/6. If I remember, theta over 360 has to be equal to the length of this arc over the circumference of the circle. So it will be length over circumference. If this is 1/6, that means this theta which is subtending has to be 1/6 of 360 degree. That means theta would be 60 degree. So if I try to join this with the center, the angle which this arc is subtending at the center is 60 degree. Now if this is the center, I would understand the length of OA and OC would become equal. If the two sides are equal, the angles opposite to them become also equal. If one angle is 60, the other two will turn out to be 60. So it will turn out to be an equilateral triangle, and I would get the value of radius as 6. So area of circle is pi r square, pi 6 square, giving me option number D as my answer. Another example, in the figure shown below, if A and C are the centers of the two circles, then X is. Now look at it. A and C are the centers of the circle. So that means this will be equal to the radius. Also, this center joined with the circumference would give you a radius. This center joined with the circumference will give you a radius. This turns out to be an equilateral triangle. And what is the angle of an equilateral triangle? 60 degrees, which is our answer. Let's move ahead and let's understand few more properties related to chords. Angles in the same segment of the circle are equal. So if there's a chord, I'm just trying to make this chord AB. If I join AB, now in the same segment, I'm talking about the major one and the minor one. So in the major segment, if I join AB with randomly any points on the circumference of the circle, so AB is making angle AXB, AB is making angle AYB, AB is making angle AZB. All the angles which it makes on the circumference of the circle, they all are equal. So if this is X, this will also be X, this will also be X. Angles in the same segment of the circle by the chord are equal, and half the angle subtended at the center. So this chord is subtending some angle at the center. Angle at the center would always be twice the angle at the circumference. So I would say angle AXB is equal to angle AYB is equal to angle AZB, and this is all equal to half of angle AOB. Similarly, in the other segment, angle APB, let me call it as Y, would be equal to angle AQB, which is again Y. This will be equal to half the angle subtended at the center. So the angle subtended in that case at the center would be double of it, which is 2y. Now I know that 2x and 2y would add up to give me 360 degrees. So I would say x plus y is equal to 180 degrees. So angle AXB plus angle APB would be equal to 180 degrees. They are supplementary angles that I have. Similarly, I would say the angle formed in a semicircle is a right angle and vice versa. So if you take a chord which is actually the diameter of the circle and try to form an angle at the circumference, it will always be a right angle. Angle formed in a semicircle, semicircle means half a circle, would always be 90 degrees. So if I try to join it here, this also will be 90 degrees. So angle which is formed outside the circle, which will be less than 90. Angle formed on the circumference by the diameter would be equal to 90. And angle formed inside the circle with diameter as the chord will always be more than 90 degrees. Let's look at an example. If the diameter of the circle is 36, so I would understand that the radius of the circle becomes 80. Okay? What is the length of the arc ABC? So I have to find the length of the arc ABC. Now I would say I would join AC. AC is the chord which is subtending an angle 40 at the circumference. So the angle subtended by AC at the center would be double of 40, which will be 80. So I would understand that the length of AC I can find out with respect to the total. So if I talk about this thing, this is 80 over 360 is equal to the length of AC over 2 pi r or pi d. I would say pi d is 36 pi. So I would find out here the length of AC. I should say this one. The smaller length I would get. The smaller length, I can just cancel this thing out. So this AC is coming out to be 8 pi. So I want the bigger one. So this will be 2 pi r, which is 36 pi minus 8 pi will give me my answer, which is 28 pi. So 28 pi is my answer for length of the arc ABC. Moving ahead, I would look at another example related to chords. AOB is the diameter. So if AOB is the diameter, that means the angle subtended by the diameter would be 90 degrees. This angle ACB will also be 90 degrees. Any 2 points joined on the circumference of the circle with the diameter as the chord would always give you an angle of 90 degrees. Okay, angle AED, okay, AED, let me call this angle as X. So AED is 90 plus X, and BCD, it is again 90 plus Y is equal to, so my answer is 180 plus X plus Y. Now look here, all my options are anyways more than 180 that I have. Now, whenever you have a question of this type, there are any 3 points on the semicircle. Any 3 point means I can assume them as the 3 points which are equidistant. I can always take a special case. If it is any 3 points, it should be applicable in special case as well. Equidistant. If I just look at it, 1, 2, 3, I have 3 points here. If I try to make a replica, I'll have 3 points here, and these are the 2 points. So what I'll get a case of octagon. And in an octagon, I know each interior angle is equal to 135 degrees. So if this is 135, this is 135, the total I would end up with is 270. As simple as that. Because if there are any 3 points, it should be valid for all the cases. I always take a special case and I get a very easy answer. Now let's talk about tangent. Refer to the figure and understand. A tangent to a circle is a line that touches the circle at exactly one point. So here, if I look at it, PT is a tangent, or PT dash is a tangent, is a line which touches the circle at one point only. Only at one point it will touch the circle. And this point, let it be T or T dash, is known as the point of tangency. Okay? The certain thing that I need to understand here is, first one being, if a line is tangent to a circle, then a radius drawn to the point of tangency is always perpendicular to the tangent line. So, if I draw a line joining the center of the circle with the point of tangency, it will always be perpendicular to the tangent line. Tangent is always perpendicular to the radius at the point of contact. The next one being the lengths of tangents from an external point. From the same external point, there are maximum of 2 tangents that you can draw from the same point to the same circle. The circle has to be also the same. So the maximum of 2 tangents that you can draw, and the length of both these tangents comes out to be equal. Okay? The third thing that I need to remember is PA into PB is equal to PT square. Now what is PA and what is PB? AB is the chord of the circle, right? Which when extended intersects at P. Then PA is known as the secant of the circle. So it will be PA, that means the length of the line from the point of intersection to a point on the circumference of the circle, into the length of the line from that same point of intersection to another point on the circumference of the circle, is equal to the square of the length of the line joining the point of intersection to the point of tangency. So very important thing is PA into PB has to be equal to PT square, and the length of the 2 tangents that you have are equal in length. Let's look at another example. Side AC of triangle AOC, not shown, is tangent to the circle with center O and radius 3 at point B. If the measure of angle AOB is 45 and angle AOB is equal to angle BOC, what is the perimeter of triangle AOC? Now for this, first I'll have to draw the circle. So what I have is, I have side AC of triangle AOC. Now if you look at it, let me take this side as AC. Okay? Is tangent to the circle with center O. So what I have is AOC. I'm just drawing that. This is the triangle. The side AC of triangle AOC is tangent to the circle with center O and radius 3. Radius, I would understand that this thing is 3. I know that this is always perpendicular. If the measure of AOB is 45, this is B. AOB is given to you as 45. This is 90, this is 45. And AOB is equal to BOC. This is also what? 45 degrees. Now I would understand that if this is 90, this is 45, this has to be 45 because sum of all the angles inside a triangle has to be 180 degree. Similarly, if this is 45, this also has to be 45. That means if this side is 3, AB has to be 3. This side is 3, this has to be 3. Why? If two angles are equal, the side opposite to them are also equal. So if this is 3, this is 3, I would get this side as 3 root 2. This side will also become 3 root 2. What is the perimeter of AOC? Perimeter AOC, triangle. So this will be 3 root 2 plus 3 root 2, which is 6 root 2 plus 6. So I'll have 6 plus 6 root 2 as my answer to this question.